Okay, so the last method of solving a probability question is using a tree diagram. Okay, so by far this is the most common type of question that you will see in O level. Okay, so let's take a look at this example 5. A box contain 8 pieces of dark chocolate, 3 pieces of milk chocolate. So there will be 11 chocolate. So 2 pieces of chocolate are taken from the box. Every time you see this sentence, you must think of your tree diagram ready without any replacement. Without replacement means you do not put back. Okay, I take one, I do not put it back. So find the probability that both pieces of chocolate are dark chocolate. Okay, so first thing first, I draw a tree diagram. So you draw the first, this is what we call the first choice. So first choice, you write dark chocolate, then milk chocolate. Of course, you put down what is the probability that you get a dark chocolate, about 8 over 11, right? Now after that, milk chocolate is 3 over 11. Okay, after that, you move on to the second branch. Second branch is right here. Since you didn't put it back, means that the total number of chocolate initially is 11. Okay, the first time you take, you are choosing choosing one chocolate out of 11 chocolate. Okay, then after that, second choice, you're actually left with 10 chocolate. Okay, so now I look at the dark chocolate, right? Okay, if you think about it, the first choice you choose dark chocolate already. So the second choice, you should not, there shouldn't be 8 dark chocolate. There can only be 7 dark chocolate. Okay, of course, the total number of chocolate is 10. Then after that, if you go to this branch right here, so the milk chocolate is still 3. Because the first choice, you're actually choosing a dark chocolate. Okay, so the number of milk chocolate still remains the same, just that you divide by the 10 chocolates that's left. Okay, now I move on to this branch already. Okay, so first, if your first choice is a milk chocolate, then after that, you move on to the second branch, which is a dark chocolate. So you notice that, okay, so this is 8. Because the first choice, I didn't choose dark chocolate. I choose a milk chocolate. So the dark chocolate should remain the same. The number of dark chocolate should remain the same. Right? Okay, of course, if you move on to the milk chocolate, because the first choice you choose a milk chocolate. So the second choice, there should be 1 less milk chocolate left, which is from 3, you move on to 2. So this is how you interpret a tree diagram. Okay, so what is the probability that both pieces of chocolate are dark chocolate? So this one is very good because I just need to consider one case, right? So I simply just choose this. So the first choice I choose dark chocolate. The second choice I also choose dark chocolate. Okay, so this one we need to use a bit of our independent event, right? So 8 over 11 multiplied by 7 over 10. Okay, so this will be roughly 56,110. So of course you can simplify. Right. So now I move on to example 6. Example 6 also very similar questions. A box contains 20 marbles. 8 marbles are white and the remaining 12 marbles are red. A marble is picked up at random and not replaced. A second marble is then picked up at a random. So you can see I choose one first, then I choose the other one. So definitely it's a tree diagram. So calculate the probability that both marbles are red. Okay, so let us take a look at this tree diagram again. So first choice, 20 marbles. So I choose a red. So there's a probability of 12 over 20. Then for the white, it's about 8 over 20. Okay, then after that, I move on to the second choice. Second choice, because you take out without replacement, means that the total number of marbles must reduce by 1. From 20 marbles become 19 marbles. So now it's left with 19. Okay, so of course, if the first choice, if I erase this first, if the first choice you choose a red marble, of course, you are left with 1 less red marble. So you must put 11 right here. I cannot put 12. If you put 12, everything is wrong already. Alright, okay, so if your first choice is red marble, then the second choice is white marble. So the white marble still remain the same. Initially, you got 8 white marble. The second will also be 8 white marble. So it's still 8 over 19. So now you move on to the white marble. So if the first choice is white marble, then the second choice is red marble. First choice white marble, so the red marble shouldn't be reduced, right? Should still be 12. So of course white marble, if you the first choice you choose white, the second choice is white, right? Means that you must reduce by 1. So this is the tree diagram. Okay. So okay, let's determine what is the probability that both marbles will be red. So I only want red. So red is just this part. Okay. So it's just 12 over 20 multiplied by 11 over 19. So that's how we solve this, right? Okay. Part 2, there will be 1 red marble and 1 white marble. Okay. So this one, imagine you choose a red marble first. Alright. So maybe I erase this. Okay, you want 1 red, 1 white, right? So first choice you choose red. Okay, second choice must be white. So you just follow the branch. So this branch is roughly 12 over 20 multiplied by 8 over 19. Okay, don't forget there's one more configuration. So if you choose white first, then the second will be red. So this is the second one. So it's 8 over 20 multiplied by 12 over 19. So you calculate what is this first, then you calculate what is this. Then of course don't forget to add up. So this is adding. Okay, so you multiply the first branch, then you multiply with the second thing, then you add up both of these probability. Alright, so that will be how you do this example 6. Okay, actually tree diagram is quite simple lah. Okay, so now I move on to example 7. So imagine we have a class of 40 students. So 24 are boys and the rest are girls. So of course we know that about 16. The girls is there are about 16 girls lah. So 2 students were chosen at random from the class. So for this example, you notice that they didn't say got replaced or no replace. So if they didn't mention, means that we just take it that there's no replacement. Means that I choose 1 student, I didn't put back the student. Alright, so I choose 1 student, left with 39 students. Alright, so find the probability that both students chosen are boy. Okay, so of course, don't need to say too much. So this is the tree diagram. So the first choice I chose boy. The second choice I also choose boy. So notice, you look at the probability of the second thing. So you notice that my total number of students become 39 already. So this is consistent with what I say. Right, so that is how you do the first part. Okay, part 2, a boy and a girl are chosen. Okay, so when you say a boy and a girl is chosen, right, means that you can either choose the first choice you can choose boy, then second choice you choose girl. Now of course not to forget, you can choose girl first, then choose boy. So you need to have 2 of these, then you add up. Okay, so I choose boy, then I choose girl. So I just use 24 over 40 multiply by 16 over 39. So this is one way, right? Okay, the other is I choose girl first, then I choose boy. So this is 16 over 40 multiplied by 24 over 39. So after you multiply all these, right? Okay, then after that you get 2 probability, you add up. Don't forget to add up. Alright, so this is something to take note of.